Welcome. Sit back, relax, and let the insight flow. Utah is an especially dry state, with water shortages frequently threatening the quality of life for everyone, and temperatures on the rise in the last several years. We wanted to see what the data says about this. We are curious to learn more about our state's climate and whether there are different microclimates throughout different portions of the state that might be more likely to experience a drought. The SNOTEL network is where we got our data from. It's a series of weather stations scattered throughout the western United States, frequently placed in watersheds. It's run by the Natural Resource Conservation Service, which is a division of the United States Department of Agriculture. The main purpose of these is to collect rainfall and other snowpack data, but they also, in recent years, have begun collecting temperature and other atmospheric data. The network in Utah began in 1978 and has since expanded to more sites with more instruments. Our data set was quite large, having over 39,000 rows. Within the state, there are 132 different SNOTEL sites. The earliest began in 1978 and others got added later. Snowfall and temperature data first begins back in 1996 when the instrumentation was added. In these two graphs, we see the first one, which is the air temperature data. It seems to be increasing gradually over time, with the two drops at the beginning and the end being from incomplete data for those years. The second graph, which is the average rainfall for each month throughout each year, seems to indicate that there have been many cycles of wetter and drier years, with the more recent years being significantly drier than the early years on the dataset. We did a clustering analysis of the different sites based on elevation, latitude, longitude, and their average rainfall. The groups seem to be overlapping quite a bit in the latitude and longitude dimensions, which is expected. And between the two different methods we used to cluster, there seems to be quite a bit of agreement between how to cluster each of the sites. Throughout our analysis, we saw many cycles of precipitation and snowfall over the years, and both seemed to decline over time. We also saw some general increases in temperature, and there was pretty good evidence to show distinct climate regions within the state through the different clusterings. The most notable of these is the Uinta Mountains, which seem to be quite distinct from the rest of the clusters.